23 years I worked for Kyoto University, and also at the Aichi University, at the Humanities University, I have taught more than about 20 years, 23 years at Kyoto University. And during this past 20 years, I learned a lot of things that I did not learn when I was a part of Kyoto University. And I'm sorry that PC is not working very well. Is it working? Good. So from many different fields and many different offices I served, I would like to share with you something that I have learned, lessons I learned. And there are a lot of slides that included into the pamphlets, but I had to selectively talk about I cannot cover all of the PPT as a part of it, and that itself is already selected. But science and technology for all is what? This is a slogan, but what is all? What is the definition of all is my first question. To a certain degree, there are many different levels of all acquisition of scientific thinking. Well, as many people talked about the humanities, whether humanities or science majors, the scientific phenomena and human phenomena, social phenomena, all these included, you have to acquire what is happening and understand the status quo, verify the fact, grasping the whole picture, and from them, that you try to extract the logical reasoning. This is the same, whether it is a humanity, liberal arts, or science. But whatever that we are considering the scientific education is that the humanity classes are rather hard to be taught of the science. And therefore, as a science, I think that the middle way between the humanity and science, that's something that we are trying to target at in this media of education. That Dr. Wyman's lecture was very intriguing to me. So how to acquire the logical thinking? This can apply to science and humanity both through education. Whenever we say science for all, many non-experts say that bluebacks, whether that Dr. Wyman knows this term or not, I don't know. But bluebacks, those people who are dedicated to explain in an easy way of the science to people. And that is one level of understanding. Oh, aha, I got science. But that is a rather low level. And some people would like to go a little further. Mathematically, scientifically, data-wise, understanding in terms of mathematical formula, this is a second level of the understanding. And those people who are further more ambitious, well, even the science majors stay at this first and second dot. But those people who are really, really ambitious would like to go even a step further away from mathematical formula, more philosophical sphere. Well, whether this philosophical part of the science can be communicated to the others, lay people, I think the answer is not reached yet. I have been teaching many of the humanities students, and to a certain degree, I hit sometimes a wall, sometimes that the wall considered to be that breakthroughs. I thought I could find of the walls between that scientific cognition and the humanity major students. Well, most of the science stay at this level. I know this because whenever that I teach the science humanities students reading books, and I read a lot of the blue books, introductory books. Well, but the students, if you don't understand, they don't understand. And if the authors don't understand, the books are incomprehensible. Sometimes really some of the so-called bluebacks books upset me. And those people that go to the third level, write the book, it's very intriguing. And so even the scientists sometimes can understand the contents of the bluebacks and sometimes cannot understand the bluebacks. I read the books so many times and knew the so-called that sometimes the challenge of the bluebacks. I read so many books because that as a part of the EINSTEIN NPO that I organized, one of the leaders of this NPO, Takuya Matsuda, says that the third level, away from mathematical formula, once that the science can advance to this third level, that they can really communicate the science to the lay people. But usually the science stayed at the second level, understanding in terms of mathematical formula. So these are my experiences. So please read these through on your own. I really wanted to get into the environment, and I have been very active in environmental protection. But in order to focus more on that, the topic relevant to today, I would like to introduce to you 1, 2, and 8. One is training in algorithm training, logical thinking. What is logic? Not exactly the understanding of science and how to develop the logic and how to extract the conclusion. And there are many reasons I started with this algorithm education. Well, I taught computer as well. And so are humanities students bad at algorithm? That's something, well, whether that they are bad or not, I don't know. Well, some of the humanities students are very logically thinking at par with the scientific measure. So that I would like to clarify on this. My classes is offered to about 500 students at the time, sometimes 1,000. In case of 1,000, I gave up because at any classroom possibly contain 1,000. So postdoctoral student took care of half of them, 500 and 500. It was wonderful for me because that we could engage in a dialogue of what is the better way of teaching. And we came to the ideas, and that is to challenge the students. And this is a way that a better way of understanding students. So splitting up the 1,000 students into two, and one, of course, that we use different classrooms at the same time, simultaneously. And my postdoctoral students and I got together after the students and compare notes. That was a wonderful learning experience for me. Dr. Wyman said that sometimes that he has to face many students, but can you imagine 500 students in front of you? In your case, you know, that maybe many of the students are highly motivated, but in case of humanities students, it's a part of the liberal art. Well, all they are interested in is just to get the credit. So they are lowly motivated. And how to motivate these lowly motivated students is a big challenge. And there is a critical point when I do that the lectures up to 200, I can keep the students quiet. But between 200 and 300 students, in case of Japan, that is, I don't know, that overseas, there is a critical point between 200 and 300 students. And if the noise started, it ramifies immediately to all the students. You have to quiet the student down. That is a big challenge to start with. And unless the students are highly motivated, they cannot keep quiet. So that's the first challenge I keenly felt. At one time, training in algorithm, I offered this class. 500 students, very, very quiet. Even the pin can be heard to drop. I will explain to you later. That are humanities students bad at algorithm? That is assumption, many people say. You know, that the writing the program is the challenge issue that we give, and use the formula for a program, for example, finding the even number, or to differentiate whether number is odd or even by using the program. There are many problems I provide, includes the numbers, of course. And algorithm itself, depending on the formula, logic is logic. So this is whether that the student's algorithm can really pursue that, the logic or not. So IBM employs many people from the humanity classes, but they provide the training and the algorithm flowchart of the lectures that I try to imitate this. Well, starting from this starting point here, and here is a problem, sample solution. Pi r to the square. I don't know. This is a program. The student is expected to make the program of calculated. And this blank here that many of the humanities students could not fill in. And okay, that reach the pedestrian crossing, you look at the light. If it is a green light, that you go, and the red, don't cross, of course. But this is a logical flow. Well, the humanities students can very comfortably can do this to make the flow chart. Now, it can be applied to the others. Every week that the contents of a lecture are instructed into that logical flow chart. I have to check the paper 500 each week, so it was very demanding. But anyway, beginning, tell students to stop chatting. And are they quiet? Yes. And start lecture, no, and then tell students to stop chatting. That was a flowchart of one of the students. Well, wonderful. This is a wonderful flowchart. And another student said that topic was environment. Another student interpreted my lecture like this: up all night preparing the school festival, fall asleep, wake up, and topic on the electric microscope, and I'm a very bad student. That was a conclusion of the student. Okay, fine. Well, this is just a chronological development. I explained to them, this is not the logical thinking. This is just the chronicle lineup. But little by little, they improved. Remember, these are humanities students. Again, begin. No paper comes. Well, I distribute papers so that we started chatting. And section 6, history of medicine and life science, I learned and end. That was a conclusion. Well, this was the beginning of the class semester. But look at this. That began from cell to bacteria. And I was talking about the Dr. Noguchi Hideo's history. And a topic of Hideo Noguchi goes on, and bacteria to the virus. The topics of the Hideo Noguchi goes on, and I explained about the episode and failures, and the Dr. Noguchi was cheated their fiancé, and the students are so intrigued of this. Well, you see that they didn't care the bacterium, and when suddenly that when the Hideo Noguchi, that how much of the cheat he was to the fiancé, okay, that's totally related with the mainstay. But anyway, that topic changes from the bacteria to the viruses, also touched on the AIDS, because that was a topic of this society, summary of the lecture, and end. So that the better example is that I taught the waste of the environmental issues. I explained that, do you think that waste as a recyclable things? Recyclables and the cost at the production stage, that I explained the two differences. And I cannot talk simultaneously, so that I go one by one. However, that I was intrigued that the students logically separated the talks in two and presented the excellent cases. The students even further improved the skills of presentation. And the class are very quiet, because that the students have to listen to, because they have to create a flowchart later. Working very hard, and the other students start to admire those students are taking notes furiously, and useful when writing other reports, they mentioned, so that the logical flow or the flowchart was very helpful for applied to the report writing. But the little digression because I had a hard time. I learned in a very hard way when I spoke too much of the fiancé of the Dr. Noguchi. Anyway, that engrossed in the flowchart and neglected the contents and become accustomed. Not only that the teachers, the contents, that many of the students says that let me add my own thinking, which was very good. And toward the end of the semester, look at this. When I explained about the energy, and you can see the problem of resources of energy, waste concept. I think this is a wonderful way of proving the students are understanding, grasping my contents of a lecture very, very well. But 500 of such report every week, sometimes it's too much. Well, a teaching assistant can be very actively used in the United States, but I had to do it all myself, checking the paper, 500 one week, but it was exhausting. I was just exhausted. But it was a learning experience for me too. And afterwards, this year, that I touched upon that the intellectual property, and I let the students write the algorithm or the flowchart of protection of the intellectual property. This is the last class of mine, so that I decided to, choose the difficult issue, not only the intellectual property that includes the art and literature and the business or the patent and copyright. There are two categories of the intellectual property, and I elaborate further on. And many of the students are making fantastic progress. So meaning humanities students, many of them are very good at the logical thinking. They are not as weak against the algorithm as many of the science teachers say. So the newer challenge, you see that the flowchart has just two branches, yes and no. But sometimes the tree chart has 3-4 branches, and I allow them the 3-4 branches, and they apply this also. So this is my experience. My question to you, Dr. Wyman, is that what do you think? Logical thinking, do you think that you can improve the logical thinking by practice? I ask you this question because how much that you can train, improve the logical thinking or logics, I don't know yet. When I'm teaching the Excel program, this and this and this. If there are two girls and one girl says understand very well, but the other no. Very serious students and two very good friends, but it's apparently extremely difficult for one girl to grasp the Excel and also that the procedure of the teaching, so that I'm interested in what separates the rather poor students of logical thinking or good student of logical thinking. One wall here is professional and non-professionals that you mentioned, the novice and expert. There is a wall of jargon. Technical terms, how to deal with the technical terms of the issue. The concept of entropy that I taught when I taught the issue of the waste treatment. And logarithm is always necessary. Whether to teach or not teach a logarithm, that was my big worries. Well, sometimes they said that the 10 or the digit, 10, 100, the 2-digit, 4-digit, and 8-digit, and logarithm was a part of the digit. And then psychology teacher says that, no, you are teaching a wrong thing. Why you use a logarithm? Because it is convenient. Then you have to teach the students that to use a logarithm because, see, it's very easy to use. Whenever there is a log, ring the bell. Ring the bell, that is, that I don't know whether, but you have to stop that resistance to this jargon of logarithm. This is, I think, the part of the cognitive psychology, to stop the resistance. Well, I think that once that you are comfortable, it is very usable. For example, when I taught the statistics at first, sigma was used. Sigma is, that to add up everything, that is a sigma. And many people say that, how many of you hate sigma? All of them raise hands. And many of the students said that hate, the students say hate, they are those people that who learned in the high school. And they couldn't understand, so that there is the reaction of resistance. Those people that were never learned about the sigma, there are no way that they show that the response, resisting response. So that I taught the sigma. I had to take the sigma 1 to 100. X plus 1, x plus 2, x plus 3, x plus 2, 100. Hey, this is very inconvenient, but sigma represents everything. And the student immediately says, hey, this is usable. This is neat. And the sigma, that is a very funny letter. That is a Greek. It's an ugly word, ugly letter. And just as that the students practice alphabet, that I let the students repeat sigma 20 times. 20 times. I don't know whether the 20 is a scientific term, scientific data or not. Repeat 20, and the students get very comfortable. And those students first said that I hate sigma. This is an ugly letter. After 20 times of repeating sigma as a letter, they don't care. So that was a part of my experience also. I guess that in the United States, there isn't too much of the separation with humanity and science. But in a high school, already in Japan, that the students choose one or the other. And well, many of the students that come to me do a little bit of the mathematics, not physics. And you see that those girls that who try to measure in the physics are wear the glasses, nerdy girls. That is probably the stereotypic of that the students, especially the girls who like physics. But in Japan, there is a very, very clear separation of the scientific students and humanities students. Now, next, experiment. Experiment, which is very unique, very different from the former one. There are 700 humanities students. To these 700 students, it was so hard to squeeze 700 all in one class. Anyway, that mainly from the departments of the business administration and the School of Law. So the experiment went like this. And some of you know that Ising model, the atoms. The atoms are sometimes function as a magnet, that whether the magnetic that face upward and downward, and it offset each other. But if you reduce the temperature, all of them start to face the same direction. Why? Why? That the cold temperature, well, this is the phenomenon called sauteing. Why the cold temperature align the direction? And this is a destruction, a voluntary destruction of the symmetry. Some of the physicists explain this way. So the destruction of the voluntary symmetry. But in order to explain to this, okay, upwards and downwards directions are codified. My textbook are codified, color codified. Up is a certain color, bottom is another color. And choose the color, I said to this. And look around, look around. Look at the colors in front, behind, to the left, and to the right. Change the majority of the color. Red and white, 700. It takes 15 of the whistling. Well, at first, that it was very difficult for the students to understand what we should do. And in 15 minutes of time, and then that in identical color disappears. See, this is magnet. When all the colors are the same. Well, sometimes the student does not change all the way, the color. Why? And well, that it was a Chinese overseas student, and therefore that he or she could not understand Japanese. That's why that he or she could never change the color. So tane or the breakage of that, well, consider yourself as an atom. And this is the breakage or destruction of the voluntary symmetry. And then the students say, it's like a fashion, it's like a voting. So this was a starting point, and what happens? And this is a computer. Well, this can be done by computer simulation, but the human being students can participate, and all the same color appears with a little bit of that increase of the temperature, and then you can allow the free movement. And once in several times, you check the color, and you choose the color you like, and then this means that the increase of the temperature, the noise comes, and many of the different direction starts, and therefore that only this kind of the one way of the direction is only possible when the temperature is low. The temperature is up, and then the atoms start to move freely. And another experiment. Well, this was highly evaluated by that physicist magazine, Nuclear Fission Experiment in the Classroom. And uranium, big nucleus, which is that the proton and neutron, and Miss Neutron and Miss Proton can be included into the nucleus. Some of the students says that, hey, don't treat me like a baby. I understand neutron, but anyway, that the big ball of the uranium with a neutron and proton, and in case of uranium-235, and then break up with one collision of the neutron, and two neutrons comes up, and this neutron collides with another nucleus, and there is a chain reaction. Chain reaction is experiment in the class that I give a cue, and the three neutrons are thrown, and from 1 to 3, and all over the class, that there will be a lot of balls jumping all around. If this takes place, this is a nuclear fission, and the release a lot of energy can be used. So this is my explanation of the nuclear fission experiment using students. So what to use at the beginning was the issue. You know that we cannot soil the classroom, and so but I use the candies first. That I had to pay 30,000 yen for buying, and I distributed the candy balls, and the students started eating the candy ball, and that was I had to stop it. So throwing 3 candy balls to around all over. But candies are expensive, and it's very it hurts you. It hurts you when you hit you. So it had to be wrapped in a paper, because otherwise it will make the classroom dirty. But anyway, that 10 more minutes, okay. That I end up with the advertisement paper rolled up in roll, free of charge. But I ask the students to pick up all the garbage in a plastic bag later. And the students really obey me. And it was a very, very popular class, and they had a huge fun of this experiment. So at the time, this was immediately at the time of the JCO nuclear accident. And uranium-235, the students knew very well, because they were the uranium-235. The student came to us and hey, Dr. Bando, that we could understand that what happened at the nuclear power station immediately. 1 year later, even, that they remembered. So you become the atom. You become the uranium-235. And that was my unique experiment, but what do you think? From the point of view of science education, from the cognitive psychology point of view, what do you think? I think this is a rather unique experiment. However, that we could eliminate the obstacle of the technical terms, uranium-235, and the critical mass, chain reaction, uranium, protons, and neutrons. And if the nuclear neutron drops in between, it's almost like pushing the control rod into the reaction, so that it broke the obstacle wall of the technical terms. And the students start saying that, hey, this is just like the fashion and trend or the voting. And hey, Dr. Bando, that I understood very well because of an atom. Not only that in my university, and I was invited to Nagoya University to do this, and the senior students of the physicist major said that it was the eye-opening experience. So this is sort of a hands-on experiment and simulation. And Dr. Wyman very aggressively visually use the result of the experiment by simulation. So what do you think? How do you compare that experiment using the body of the students itself or simulation? Real versus virtual. Analogy, how effective do you think the analogy is? This is my second question. That the slow neutron is good for controlling the fission. I was asked by the students, and I said, okay, if the beautiful woman pass by and you try to stay, but if you're running at the high speed and then that you don't see that the girl is beautiful or not, and that was, I don't know whether that the explanation was good or not. But anyway, and next is e-learning. I want to numerically explain the e-learning. That the training is done by e-learning at us. So I would like to explain to us that the language or that information literacy education is best suit of the e-learning, in my opinion. First, when I asked them, and I asked that there are two people who are computer literate people, and those people who are graduate of the vocational high schools, and from the normal high schools that they have never used the computers, two groups. And I gave the quiz, just as Dr. Wyman says, to test previously. And there was the 2 polls, or the 4 polls actually. I divide the student into 4, and this is a structure, overall structure. That we classify the students to 6 or 8 quizzes, and if they take all the 8 quizzes successfully, and they pass the course. At the beginning, you see that they make a very fast progress, and of course, this is a learning curve, and there are many people who've successfully passed the quiz. The second level, and those people who started later and go up 4, 5. That the harder the test that they take later and draw this curve. And so this is the number of the successful students. And ultimately, you see that generally that we get the normalized distribution. However, what was very intriguing of this is that there is a big difference of the women and men and women. Well, at the beginning, the elementary tests, that most of them are the female students, girls. I was wondering because many girls come to the elementary class, but the boys come later to take the quiz. At the beginning, at the end, really, that many of the boys rush to rush to the class to take the examination to pass the course. So this is a rank A, B, C, D at the beginning. That the ranking, the A was the early taker of the quiz, and B, C, D latecomers also achieved ultimately. So I think that the e-learning is good for the normalizing, and depending on your level of the previous knowledge and the progress speed. But more intriguing is that the gender difference. At the beginning, it's that the female. In the end, that the boys come up and end up 50-50. I think this is a common trend. What does this mean? That women try to prepare early and do a steady work and start earlier. And the boys tend to rush in at the very end. And women have superior grade in everything. That's probably the reason for this. So using the e-learning clicker, sometimes the people use the cell phones instead of clickers to check how much the students can understand the contents. I believe that there is going to be the advance of the quick feedback and adjusting the course of lecture depending on the feedback and the level of understanding of the students. In this case, digitalization, e-learning, and many simulations for helping the understanding. I think this is the age that we are in right now. But what is the issue is that the teachers cannot catch up from Japanese comedy to the Disney movies. Well, the comedy show is just on the stage. But if you make the movie out of this and disclose, everybody can learn. It is possible to use images in education to have the little bit of element of man-on-man dialogue and one against all. Well, this is a part of the effect of e-learning, but I think that the teachers have to do a lot better jobs. To me, the e-learning is for the evaluation of the level of the understanding of the student, clickers and e-learning as well. So I have used up my time, right? And just one more point, exercise in Excel. This is just an example. This is a part of the information literacy education. And there's a table of population and the area and calculate the population density. And there was a question. Dr. Bando, where is this function? Where's the function of this? It is just a division. What do you mean by the function? For my students, you see, all these should be included into the program, as a program is a black box. That's why that the student asked, hey, where's the function of this? Not only the humanities students, science students even. This was a data provided by Dr. Kazuo Nishimura. And as a scientist, I believe that the scientist employed by Toyota, and this is the examination they have taken. Well, how many grams is 10 kilograms? And this is elementary school's problem. Volume of the triangle pyramid, less than 50% of the rate of the correction. So there's the science students doesn't have too much to boast about. Because probably that they consider the formula to be remembered. The distance equals a speed times time. DST. Well, if you forget this formula, that's the end of the story. So that's why the scientific students, science majors, are as poor as the humanity majors. Evidence-based, we have to grasp or confirm the effect of the science, whether it is, well, we are not saying that which method is bad or good. We really have to date based upon the data to really find that sustainable education method by constantly improving. Thank you.